Extraction of copper from cuprous oxide. Now let's see which is a suitable reducing agent to reduce cuprous oxide to metallic copper. From the Ellingham's diagram you can see formation of cuprous oxide line lies at the top, whereas after 500 Kelvin formation of carbon monoxide or carbon dioxide from carbon line lies at the bottom. So you can very well use coke as a suitable reducing agent. Now you may ask why coke should be used as a reducing agent, why not other metals? The answer is coke is the cheapest and most abundant reducing agent. So when you are going to use coke as a reducing agent, extraction process becomes more profitable. Now let's see the various steps involved in the extraction of copper. Around 85% of the copper is extracted from its sulfide ore, that is copper pyrite. Chemical formula of copper pyrite is CuFeS2. Since it is a sulfide ore, it is concentrated using Froth flotation process. We have learnt about this Froth flotation process in detail in concentration of ores. The second step involved in the extraction process is roasting. In roasting, concentrated ore is heated in the presence of oxygen in a reverberatory furnace. So moisture present in the concentrated ore will be removed. Volatile impurities will be removed, as well as non-metallic impurities such as sulfur will get oxidized to sulfur dioxide, phosphorus will get oxidized to phosphorus pentoxide, and arsenic will get oxidized to arsenic oxide, and those oxides will also be removed. Then the copper pyrite will dissociate into individual sulfides. We know copper pyrite is CuFeS2. So that upon oxidation will give you cuprous sulfide and ferrous sulfide, as well as sulfur dioxide will be removed. Apart from that, small amount of cuprous sulfide will get oxidized to cupric oxide, and small amount of ferrous sulfide will get oxidized to ferrous oxide. The next step involved in the extraction process is smelting. The roasted ore, coke and silica is called charge. Role of coke is a reducing agent as well as it acts as a fuel in the extraction process. The role of silica is flux. It will react with the gangue particles and forms a molten slag which can be easily removed. The charge is added to the blast furnace and simultaneously hot air is blown from the bottom of the blast furnace. So ferrous sulfide will get oxidized to ferrous oxide, which will combine with silicate impurities present in the ore, that is SiO2, to form molten ferrous silicate. This molten ferrous silicate will be called as slag and it flows down to the bottom of the furnace. So when we remove this slag, the silicate impurities present in the ore can be reduced. Next, the molten iron sulfide and cuprous sulfide will form immiscible mixture called coppermate. This coppermate also flows down to the bottom of the furnace, and we have two separate openings to remove slag and coppermate. In the examination point, what is coppermate is an often asked question. Last step involved in the extraction of copper is Bessemerisation. The molten coppermate and sand is taken in the Bessemer converter lined with calcium oxide or magnesium oxide. Then hot air is blown into this Bessemer converter using tires. The hot air will oxidize the remaining ferrous sulfide to ferrous oxide. This ferrous oxide will combine with the silica impurities present in the coppermate to form molten ferrous silicate, which will be removed as slag. Then this air will oxidize some of the cuprous sulfide to cuprous oxide. This cuprous oxide form will act as a reducing agent and it reduces the remaining cuprous sulfide to metallic copper. This reaction is found to be highly exothermic, so the copper will be formed in the molten state. When the molten copper solidifies, sulfur dioxide will be evolved, so it appears as blisters on the surface of the copper metal. Since the solidified copper has blister appearance, it will be called as blister copper. In the examination point, what is blister copper is an often asked question.